Hello, chemistry students. Today we're going to continue our conversation on solutions, and we're going to talk about rates of dissolution and solubility in this video. First thing you need to know is like dissolves like. Polar and ionic solutes dissolve in polar solvents. Nonpolar solutes dissolve in nonpolar solvents. The rate of dissolution is simply how quickly a solute dissolves or how quickly it can dissolve. Solubility is the amount of solute, remember the thing that you're dissolving is called the solute, that dissolves at a specific temperature. Rate of dissolution and solubility are often confused. They are not the same. The rate of dissolution is how quickly something dissolves. Solubility is the amount that can dissolve. Okay, now let's go through this chart here. So we have dissolution rate of a solid, so how quickly a solid can dissolve. If you heat a solution, it increases. We know that when people make Jell-O, they always heat up the Jell-O before they heat up the water before they dissolve the solid in there, because it makes it dissolve quicker. If you agitate it, that also increases the dissolution rate. You can stir your tea when you add sugar in it, and it will dissolve faster. Or you can stir your Kool-Aid mix, your water in your Kool-Aid mix, and it'll dissolve faster. Or if you add one of those drink mixes into a bottle of water, you typically put the bottle cap back on and shake it. Now, if you increase the surface area of the solute or the thing that you're trying to dissolve, that also increases the rate at which it will dissolve. And increasing the surface area means if you crush or grind it. So if you have a piece of rock salt and you put it in some water, and then you have the same mass of granulated salt and you put it in some water, the granulated salt will dissolve faster because there's more surface area for the water to touch. Now, if you increase surface pressure, that has absolutely no effect on the dissolution rate of a solid. Now let's talk about solubility of solids. If you heat a solution, the solubility of a solid will increase. The amount that you can dissolve will increase almost always. If you agitate the solution, if you stir or shake it, it has no effect, because the amount that can dissolve has absolutely nothing to do with if you stir or shake. Now, the rate at which it will dissolve, how quickly it will, has something to do with that, but it has no effect on how much will dissolve in there. You can't make more sugar dissolve in some water just by agitating it. At some point, it will stop dissolving no matter what you do, as far as shaking or stirring. If you increase the surface area, that has no effect as well. Once it's reached its solubility, it cannot dissolve anymore unless you increase the temperature. If you increase the surface pressure, that also has no effect on the solubility of a solid. Now let's talk about solubility of gases, when a gas is dissolved in a liquid. Okay, if you heat your solution, gases have a tendency to come out of solution. Usually people put their Cokes and whatnot in the refrigerator, and the reason why is because it will keep the carbonation in there longer, or at least that was the original reason. Now it may just be because you want it cold. And if you heat it up, it will come out of solution. Now let me tell you this, you cannot typically see a gas that's in solution. It just looks like a homogeneous solution. You cannot see it, but once it comes out, that's when you see the bubbles. That's when it's coming out of solution. It's like a precipitate as far as a solid is concerned. If you see a gas bubble, that means the gas is precipitating out of the solution. Okay, agitating it. If you take a Coke and you shake it up, the gases will come out, so that decreases the solubility of a gas. The gas will come out of solution. You see more bubbles. Increase the surface area of a gas, that has no effect. No effect at all by crushing or grinding gas, which is kind of odd, which you can't do. Increasing surface pressure. Now that will increase the solubility of the gas, which is why all of the soda bottles are under high pressure. You can take a bottle that has not been opened or a can and squeeze it, and it's very difficult to squeeze. But once you open it up, you hear that psst. That's gas or pressure being released out of the bottle, so you're decreasing the pressure. When you do that on a Coke bottle, you can actually see as soon as you open up that can top or the bottle top, you can see the gases form on the sides of the bottle and come up out of solution. And the reason why is because you're decreasing the pressure, which decreases the solubility of the gas, which means the gas will come out of solution, which is why you see the bubbles.